Okay. Now we've already seen the example of compound interest, where, for example, your principal, looking for the word, sorry, where your principal grows by 6% or 12% or whatever every year, or grows by some fraction of that every so many weeks, months, or whatever. Okay, so those are examples of growth at a constant growth rate. And don't confuse growth rate with rate of change. Okay, rate of change is change in y over change in x, fundamental triangle. Okay, growth rate is a different use of the word rate. It's related, but it's not the same thing. Okay, now let's suppose some quantity q, and I'm not going to specify what quantity it might be, something hopefully important, starts out at 100 and changes at a daily decay rate r equals negative 0.1. Now, when I say constant growth rate, I really mean constant growth or decay rate. Okay? In this case, now, okay, in the case of compound interest, r might have been 0.12 or 0.06 or 0.03. It would have been a positive number because something was actually growing. Here, r is going to be a negative number, but it behaves just the same as far as the sequence of calculations. You're going to use it in the same way you used it for the growth rate of a principal. Okay, so Q starts out at 100 and changes at a daily decay rate of negative 0.1. That's really a growth rate, but it's negative, so it's a decay rate. Okay, so we're going to find Q of t for t equals 0, 1, 2, and 3. Okay, well, presumably t equals 0 is where you start out. So Q of 0 is 100. Assuming we start out at t equals 0. And that's usually kind of an implicit assumption, but it could be stated otherwise. We might want to start out at t equals 15. Okay? In which case we'd said t equals 15 is 100. And we wouldn't have been asking necessarily about t equals 0, 1, and 2. Okay, anyhow. Okay, so we should probably specify that t is in days from start. Okay, so Q of 1 is Q of 0 plus the change in Q. What's the change in Q? Well, this is what we mean by our decay rate. Well, what we mean by our decay rate is we multiply this by whatever our quantity is to get the change, just as we multiplied the growth rate by the principal to get the change in the principal. Change in Q is then negative 0.1 times Q, which is negative 0.1 times 100, which is negative 10. So Q of 1 equals 100 minus 10 equals 90. Okay. Now another way of writing this is Q of 1 is 100 times 1 minus 0.1. because 100 times 1 is your 100. 100 times negative 0.1 is your negative 10. Now we could reason out Q of 2. Q of 2 would be Q of 1 plus a change in Q. Change in Q would be negative 0.1 times your Q. Q would be Q of 1. We can shortcut this a little bit. And just say that Q of 2 is Q of 1 minus 0.1 times Q of 1. Now why is that? Well, another day goes on. Okay, after another day, it will have changed with this growth rate, meaning that it will change by negative 0.1 times whatever it started the day at. Excuse me. It's the second day, which started at the end of the first day. So we're going to subtract what we had after the first day. We're going to subtract 0.1 times that amount to get our next Q. And of course, this equals Q of 1 times 0.9, which is 90 times 0.9, which is 81. Now note that on the first day we lost 10. On the second day, we started with 90, so we only lost a tenth of that, or 9. So 90 minus 9 gives us 81. Okay, then Q of 3 equals, now it equals Q of 2 minus 0.1 times Q of 2, but that just comes out to Q of 2 times 0.9 equals 81 times 0.9, which is 72.9. Cube of 9 is 729. Okay, so there we have it. Now if we were to graph this, we would say that we start at 100, we drop to 90. Now if 80 is here and 70 is here, our next number would be 81. Our next number would be 72.9, and then so on. And so there just doesn't, yeah, okay, we're talking about 8. So it doesn't mess with that, but it kind of has to be, because I know that 9 cubed is 729. Okay, something's gone wrong in my brain here. Something doesn't look right about that 72.9, but I'm pretty sure it's right. Okay, so check me out on that. You know, check out this calculation. Pretty straightforward. Okay. Right, what I'm thinking is the change should not have changed by that much, but it really didn't. I was just doing something stupid with my arithmetic, I see. Don't worry about it. Okay, now, okay. Let's now find the function Q of n, where n is your number of days. Okay. I'm going to do that in a separate video because I want you to digest this before I go on.